Greetings and salutations! Thanks for hanging out with me for a while. In this video, we're going to look at a simple SSH setup for Ubuntu and Linux Mint. I'm going to step you through the process of getting SSH running on your local area network. So what is SSH? Well, it is the secure shell, a network protocol that securely connects two computers over an unsecured network. So pretty much everything you do through SSH, whether it be remotely log into another machine, if you're running an application using SSH, if you are transferring files from one machine to another, or you have a network share open, like where you're sharing the parts of the file system directories from one machine to the next. It's all done through an encrypted tunnel, and we really don't care how safe the network is that you're doing it on. In this video, we are going to talk about installing the SSH server. We're going to create some SSH keys to automate login. We're going to look at file sharing utilities. We're going to talk about data transfer. We'll talk about X forwarding, which is a very cool thing that SSH can do, and we will touch on scripts which automate all of these SSH utilities to do some really nifty things. Before we get into all of that, I must warn you that the procedures used here are quick and dirty. We're going to be accepting all of the defaults as we roll along. We're not going to be doing a lot of the little extra tweaks that you'll see recommended to improve security. We just want to get it up and running. And it's okay because we're going to be on a subnet. We're going to be behind a router which provides a firewall against the public internet. In other words, people with bots who are searching for machines on the internet that run SSH, they won't see these machines because they'll be behind that firewall. If you intend to set up SSH to run on the internet, if you're going to broadcast one of your machines on the internet so you can remotely log into it from halfway around the world or something like that, then do your research and figure out the best way to secure that connection, because if a machine that is running SSH is on the public internet, there are bots out there that just bang on it. I've got servers running on the internet that I administer through SSH, and every time I log in, there's this little utility that says, well, there's been 12 unsuccessful login attempts since the last time that you logged in, which is telling me that people are out there just beating on that machine trying to get into it, see? But since we're behind a firewall, we don't need to worry about that. And I also put that in there for the folks who are a little bit more advanced users who are watching this video, because if I didn't say that, they'd be like, man, you just set up one unsecure SSH network. Yeah, it's kind of the way it is, so deal with it. So in this video, what we're going to do is we're going to use the host machine that I'm recording the video on as a client, and then we are going to set up a virtual machine as an SSH server. So that's how it works. It's a client-server relationship. Pretty much every Linux distribution comes with the SSH client installed, ready to use. You just type in the commands, it'll go out and it'll connect to any computer that's running an SSH server. But if you want to make your system accept logins from remote machines, you'll have to be running the server on it, and that will have to be done with every computer that's on your network that you want to remotely access. All of my computers run SSH, and all of them are authorized with keys so that I can island hop through the network. I can be on any machine and get to any other machine. And you'll see how that works as we roll along. If that's mysterious to you right now, don't worry. It becomes pretty apparent. So the first thing that I did was I backed up my current SSH configuration. It is stored in a directory called .ssh, which lives in your home directory. So on the client machine here, I have put that in SSH backup, which means that this is an unconfigured client. This is what you're going to get if you just installed Linux or you've never used SSH. We'll configure it as we roll along. For our server machine, I have this lovely virtual machine which we are going to set up as a server. So the first thing that we need to do is we need to set up a static IP address for our server. And the reason why is very simple. Most modern routers, especially the ones that are provided by your ISP, do not have name servers running. So you'll see a lot of documentation about SSH on the internet that says you log in by typing in SSH and then you give your username like Joe at Big Boy, right? And it should log you in. Well, it ain't going to work if there's no name server running on the local area network, and most of the time these days there ain't. I haven't seen a router that has done that in a long, long time. So what we have to do is set up a static IP address, and this is actually not as hard as it sounds. It's just a matter of gathering all of the information. So what we will need to know, according to my notes here, is the gateway address, the netmask, available IP addresses for your local network, and DNS server addresses. So all of that is, most of that, let's put it this way, is available from the machine that you're working on itself. So let's jump back over in our machine here, and the first command that we're going to run is IP, and we will route. So that's going to give us our gateway, which in this case on this local network is 192.168.0.1. Now that's pretty standard for a router. Chances are your network is 192.168. something, because that's pretty standard for a local subnet, especially for Wi-Fi. It could be slightly different, but you're going to get the idea here as we roll. You'll understand if you do these commands on your own network, it'll tell you what you need to know. So we have our gateway address. We know where our router is. That is how we get to the internet and also how we get to the other machines on the network. So the next thing that we need to figure out is the current IP address and netmask, and that will help us to determine what IP address it is that we can use for a static IP. So the tool that I like to use to do that is Ifconfig. This is an oldie but a goodie. It has been deprecated in some distributions. Ubuntu does not ship with it by default. You have to install a package called NetTools. I strongly urge you to do so because I don't like the replacement for Ifconfig, which is the IP program that we've already used once, but it's just the way it lays it out. I don't like it. So where is our local network? What we're looking for is a 192.168. That is an IP4 address. So we need to find our IP4 addresses. You'll notice that we have INET 6 here a lot. That's a different protocol. We're not even going to be messing with that today. We're worried about IP4 right now. And it's behind INET. And you notice that it tells us a lot of information here. Two more pieces of the puzzle that we need to get. First of all, it tells us that our current IP address is 192.168.0.109 and that our netmask is 255.255.255.0. Now you don't need to know what that is, you just need to know what the numbers are, okay? And what this is telling us is pretty much what IP addresses we have to choose from. Usually it works this way. You can do anything from 192.168.0.2 all the way up to like 256. The router has given this machine an IP address of 109. That's the last number there in that when it logged in with DHCP. We're going to turn that off. We need to do this manually. So we can choose an IP address anywhere in that range, and it will automatically say to the router when it logs on, hey, give me this IP address. The router will say, okay, it's yours. Boom, there you go. And it'll stay that way for the entire time it's on. So what I do on my network is I start them at 11. So we'll start with Big Boy, which is machine 11, and then I've got another one that's 12, 13, 14, 15. And as I add machines, I just keep going up. In this case, we're going to make it 20. How's that? Now, another thing that we need to talk about very quickly before we get into actually putting those numbers in there is DNS, because DNS is going to go away, automatic DNS, when we start using a static IP. So we're going to have to figure out where we're going to get it. And you probably don't even know what it is. I mean, a lot of people don't know what DNS is or how this works, but what it means is a domain, hello, can he say it? Domain name system. And we need to connect to some domain name system servers. What does that mean? Well, if you sit down in front of your browser and you type in youtube.com, your browser goes to a DNS server, which is already figured out by your ISP and programmed into your router, and the IP addresses for those DNS servers were forwarded to your local machine when DHCP assigned it a local IP address. And what those servers do is they look up the name YouTube, and then they go, okay, what is the IP address that is currently being used by the name youtube.com? Oh, it's whatever the IP address is. It sends that IP address back to your local machine, to your browser, and then your browser goes, oh, okay, thanks, and it says, okay, go connect to this server running on this IP address. So that's how the internet works, ladies and gentlemen. And we need to have these IP servers, these DNS servers available to us. Your ISP runs DNS servers, all of them do. So if you have like Comcast, or if you're running whatever, it doesn't make any difference. You can go look it up. You can just look up your ISP's DNS servers. You could use those if you want to. I prefer to use OpenDNS, and one of the biggest ones is provided by Cloudflare. And what that is basically, instead of going through your ISP, which is using that information to see what websites you're connecting to, we go somewhere where they're not doing that. And if they are doing any statistics, they're extremely anonymous. They don't care who you are. You don't have an account with these people. It's just, here's DNS servers. So I use 1.1.1.1, and the backup for that is 1.0.0.1. And you can learn more about that if you want to. I've provided the address here, and that'll be in the notes for this video down in the description. So that's what we're going to use. So now that we've got that all figured out, we're armed with all of the information we need to actually set this up. Let's go in here and set up this static IP address. Now you can do this using Network Manager, and you have a little applet that runs. This is slightly different depending on the distribution, but you've probably already gotten in here before. So we'll open this up and we'll edit it. And what we're interested here in is IP4 settings. And we're going to change that to manual. And then we're going to add first our address that we're going to use. And in this case, I'm going to do 192.168.0.20. The netmask is 255.255.255. whatever, right? But there's actually an abbreviation for that. It's 24. So I'm going to put that in there, and it will accept that. You can try that if you have the same sort of local area network. Now we need to put in our gateway, and we learned that that is 192.168.0.1. That is the address of the router on your local network. Now we'll need to put in our DNS servers, 1.1.1.1, comma, 1.0.0.1. That's the backup server for Cloudflare right there. So if 1.1.1 is not up, it'll try the second one. You can have as many as 3 or 4 of these in there. And some applications that do exactly the same thing this does, they don't allow you to put in the comma. What you have to do is press a little button over on the left-hand side that creates another line. It's sort of like this, where we could add another address here if we wanted to, another set of addresses. We're going to leave that just the way it is, and we need to require IP4 addressing before we get a connection. In other words, it's going to make sure that this is working before it does anything else. For IP6 settings, what I like to do is just ignore it. It's not going to turn it off. It's just going to make it where it really doesn't have anything to do with what we're trying to do. That's going to work differently. So we will save that. And now we should have a static IP address. We're not going to get it until we reboot the machine, though, because we're going to have to restart all of the network stuff to make that happen. And logging out and restarting doesn't seem to do it. I've tried like Systems, CTL, Restart Network Manager, and it doesn't change it and stuff like that. So for you more advanced guys that are going, you don't need to reboot. Yeah, you do in this case. So the next thing, once we've set up our static IP address, is that we need to install the server. Before we do that, we need to address an issue with the firewall though. So what I'm going to do is I'm going to go in here and go to the control center, which is what this distribution has. And we're going to go find the firewall configuration. And we are going to, there it is right there, make an exception for SSH. If we don't, then what's going to happen is the server is going to be running in the background. We're not going to be able to get to it from the client. I made this mistake while I was getting ready to do this video, and I was sitting here going, why can't I connect? I was like banging my head against the wall going, I can't believe this. I'd forgot that I'd configured the firewall on this machine. Because it's a virtual machine, right? But I usually set up a local firewall on all my machines, just in case some nefarious character gets in my internet. He won't see anything, right? But what you need to do is you need to make a rule for SSH. So we do SSH. And it's going to tell us, you know, this is dangerous, be careful, it's a security risk, blah, 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 blah. It's referring to being on the public internet, not on our local LAN. So this wouldn't be a good thing to have up and running when you go to the coffee shop, let's say, and you're going to use public Wi-Fi. So you'd want to have two profiles for your firewall, one for when you're at home and one for when you're not, and switch them around. That's be the way you did it. So that's how you create a rule with a little GF. That's the GUFW firewall that comes with a lot of Linux. It comes with Linux Mint, and most of the Ubuntus have it available as well. So now what we need to do is we should restart this machine. And we can do that quite simply. Let me just open up a terminal here, and we will just, oh, well, we're not going to restart it yet. We need to do one more thing. We need to install the server. Daw Louie, George. That's real important. Well, we could reboot it and come back and reinstall, but almost forgot completely to do it. So to install the server on Linux Mint or Ubuntu, you just do you spell it right. And that's it. You should also probably, when you install this, I'm just going to go ahead and do it. We'll talk more about this little package later, but we want to make sure that Sshfs is there as well. So that looks good. Oh, you dummy. No such file or directory. You all were laughing at me and pointing at the screen. I was so concentrating on what packages that I needed to install. I forgot to put apt in there. See, I leave those mistakes in because everybody makes those dumb mistakes. I'm sitting there going, what did I do? Did I misspell it? What's wrong? So we'll go ahead and install that. And then once this gets installed, all I got to do is reboot the machine, and we should be ready to rock and roll. Our virtual machine is all booted up. As a matter of fact, I'm not even going to log into it. I'm just going to let it run just like that, because from now on we're going to be accessing it through SSH. So let's go look at our notes real quick and make sure that we've got everything going. So we have got our static IP address. That's working properly. We've installed the SSH server plus that little extra package. Once installed, the server should automatically start itself, and the machine will be waiting for logins from other machines on the network through port 22. We have made the exception for port 22 in our firewall. So let's go ahead and log in. And the first login will be SSH, and then we will use the IP address for the machine. Now, one of the things that you're probably wondering here, well, I've seen where you put your username first, and you would do that if your username on the machine that you're trying to log into is different from the one on your local machine. What I do is when I set up all my computers, I make sure that the usernames are all the same so that I don't have to do that. So let's do SSH 192.168.0.20. Let's see if we got it right. So since your client has never seen this server before, it's going to confirm, do you really want to get in here? Is this a trusted machine? We're going to say yes. Then it's going to ask for the password. This is the password of the account on the machine that we are logging into. And we are in. We are actually on that other computer right now. And this is what it looks like when you log into Ubuntu from the SSH. This is what you get. So we'll go ahead and exit out of that. We know that works. So the next thing that we want to do is we want to create keys so that what we can do is just not have to give it a password when we log in. This is really nice on local networks or on servers that are up in the cloud. We talked a little bit here in the notes about using Ftp. We'll talk about that later. You can automate, or rather just make that a little bit easier by creating an alias where you use this little stub of a script. You basically alias this command right here. And what it does is it makes it so you don't have to type all that in. And I'm going to use that from this point forward. So let's go ahead and generate our keys. We'll go back to looking at SFTP and other stuff like that once we get this part done. We're skipping ahead just a little bit. So here we go. The first thing that we need to do is we need to generate keys, and we're going to do this on the local client machine. We're going to be on our client doing this. So this is the client. Let me clear the screen. Control L does that in most terminals. And we'll just type in this. And we will go forward. Just enter. And it's going to make sure that we want to use this file name, and we're going to put it in a directory called .ssh that is in our user directory. We will accept that. That is fine. You can do different options here. You can give your key file a different name, but the thing is that if you're going to be doing that, then you're going to have to specifically put all that information in when you do anything with it from this point forward. So we're just going to make it real easy. We're going to assume you're going to create one key. We're not going to use a passphrase. A passphrase will replace a password or work in addition to a password with a key. So this is an extra little bit of security that you could put in. This is great for public internet SSH machines that you want to put keys on. For a local network, it's just, we're doing this to eliminate having to type in a password. So we don't want to type in a passphrase. So we're going to skip that. Just hit enter, and that's it. And now it has created a very small key. And we can confirm that by just looking in the SSH directory to make sure our keys are there. LL, by the way, is an alias for LS with the long format that shows us everything about the files, which is exactly what we want to see. And you see now we have a couple of files in here, so we'll stop and talk about this. The first one, this is our private key. It says ID RSA right there. This key is your key that will be compared against this key on a server. This is the public key. This is the one that you will put on a server somewhere, and then it will compare these two keys and it'll make sure it's you. And then finally, known hosts. That is what was created when we logged into our first SSH server and answered yes. It took the secure information from that particular server and put it in here. So in the future, it'll know that that's an okay server. If the key on the server changes, we're not talking about the public key or your private key, we're talking about the server key itself. If that changes, then you're going to get a message that says, hey, something's wrong. This isn't the same place. Something's changed here. Now, what that usually means is that somebody's reinstalled Linux and they haven't backed up their SSH directory out of the etc folder and restored it as was. When they reinstalled the server, it created new keys, and that's all it usually is. So if you know it's a trusted server, if it's your own server, for instance, most likely you can just follow the steps that it gives you when you go into a server that's changed it. It has a big message up there, and it says, okay, fix this, doing this, and then you can log back in. So those are the files that we are currently working with. But what we need to do to make this useful to us is we need to copy it to our server. So we're going to use a command that makes this super easy. So we'll do SSH Copy. I'm going to autofill that. And now we want to go ahead and give it all the information. So we want to send this to joe@192.168.0.20. So there's our server. Let's see if it works. Okay, so we have to give it a password, so make sure that it's us. One more time. All right, now it's sent it through. Now let's see if it works. And I'm using my shortcut here, gang. Let's see if we are prompted for a password this time. No, we're not. So that means this worked the way that we wanted it to. So let me show you what's happened here so that you understand. So let's go into ll.ssh on this machine. Now you see we have two files in here. One of them says authorized keys and the other one says known hosts. That's where your public key is. It's in that file. So if you wanted to set this machine up so that you could sit down in front of it and log into other machines, all you would have to do is copy your local key, your local personal key, which is IDRSA, into this machine directly. And then you take that authorized keys file and you put those two files in any SSH configuration directory for any account that you have on any machine. Suddenly, you don't have to type in a password anymore, and it automatically knows who you are. So let's do a little island hopping right now. Let's hop back in and grab a file here. I'm going to show you the first utility, which is the one that I use all the time for file sharing. Let me go ahead and clear the screen. So remember, we are logged into that virtual machine, and we are going to now log into another machine from the virtual machine. So let's use SSHN11. Yes, I already have my little script in here, so this will know what to do. And it asks for a password. So now I am logged back into the host machine. And I did this just to show you how island hopping works. Now the reason why it asked for a password when I did that is because I don't have that authorized key, or it's not set up with keys in this direction. We're going to take care of that right now. So we're going to use a program called Sftp, which is my preferred way to do file sharing. Actually, what we should do, I did that wrong, ladies and gentlemen, is we need to go ahead and exit that. And then we use this sftpn, same sort of shortcut, 11. Okay. And so what I'm going to do here, let me go ahead and clear this, go up to the top of the screen. It just says SFTP. So it'll give us our present working directory. This is on the machine that we're logged into. And if we want to know for our machine that we are doing from, we do lpwd for local pwd. So those are our working directories. So right now they're both /home/joe. We need to change those for what we need to do. So we're going to cd into .ssh. And then I am going to cd lcd, which changes our working directory on both machines to .ssh. And I'm going to get the IDRSA. I'm going to bring that back over here. All right. And then I'm going to put, which means I'm going to send something, authorized keys. And what that's going to do is that's going to put it back over there. So let's do that again. Let's list our local directory that we're working in. You see now the local directory, this is the remote directory. I don't mean to confuse you. This is the machine we're logged into, which is remote. You see now we have authorized keys, ID RSA, and then we have our public key and our known hosts. So let's do the local machine. Remember, we're logged in from the remote. It'll make sense in a minute. So now you see we have ID RSA and authorized hosts. So let's go ahead and exit here. You can type in exit or you can type in BYE. All right. We're going to exit this server. So now we're back on Big Boy. Okay. So let's see what we need to do here. Okay, so let us log into that one again. So we will do 20. Now we are going to SSH into 11. This time it's not going to ask for a password. And it logged us straight in. So that's how you set it up if you want to island hop around your network. You need to make sure that those two files, authorized key and your ID underscore RSA, are in all of the directories. And you can actually just back up your SSH directory, your little configuration directory we talked about there, and then we copy that over to new machines, new installs, and every time it'll just automatically be there and you're already up and running. Pretty cool, huh? So let's go ahead and get out of here. And I want to make sure, I know it sounds silly, but I want to make sure I'm okay. I didn't know how many hops I had. You can set up multiple tunnels running back and forth. So basically, we have just set up SSH between these two machines. We have a nice little SSH network going. We have servers running on both machines, and we can log in either way. So we have two-way SSH access, which is pretty cool. Now that we've got that all set up, you can log in automatically, and what you might consider doing is going into the configuration files for SSH and turning on password access. Now what that will do is it'll make it so the only way that you can actually get into the servers is by using keys. That's extremely secure. Of course, behind the router on the local area network, that's not something that you probably need to do. What you can also do, well, I wouldn't do that because when I set up a new machine, I might not have the keys over there. But what you can do is go ahead and turn that off, and then when you do set up a new machine, you just copy in those files that I just showed you, and it's already ready to go. It should work immediately because it will just compare the keys. So it makes it super secure. I don't bother to do that because I'm lazy, and if I have a new machine or a virtual machine, for instance, a lot of time with virtual machines, I don't go through the trouble of setting those up to have static IP addresses and all that kind of stuff. It's just kind of a, too much of a deal there. So we will need to use some tools. We've already looked a little bit at Sftp. We want to take a look at Sshfs, which is actually a very, very powerful tool that allows you to do network sharing of directories on machines, and this is encrypted network sharing, which means that once this is set up, you're using a secure tunnel to do that. So let me open up a terminal yet again. Nice clean terminal here, and we're going to start over. And what I'm going to do before I do this, I am going to go ahead and restore my old SSH directory. So let me go ahead and get rid of that one that we just set up, just like so. And let's see, we need to move SSH back up to .ssh, like so. All right, so now I'm on my regular network, so I can go get into another machine and play around and show you this. So let's do Sftp real quick and do it on a machine that has some files in it. So we'll Sftp into 13. That's the one my son is using right now to play a bunch of games. Let me get that out of there. Sftp. Well, you forgot the T, man. You got to put that in there. Okay. So we're going to jump into that machine, and it put me right in. So this is the home directory on that machine. So if I cd to bin and I do ls, then we are in bin on machine 13, and I can once again grab or put files. You can also do entire directories this way if you want to. So you just do it recursively. So let's see here. Let's cd ... That should take me up one level. So if I wanted to grab the bin directory out of this machine and replace the one that's in there, I'm just going to show you. We would get. So this is going to grab it from the other machine and pull it to this one recursively, and then bin. So I'm pulling this when I'm pulling from the remote machine we logged into, and it brings all those like that. No big deal at all, right? So you understand how there's actually a lot more commands that go with SFTP. It works like the old FTP protocol program. So we've already looked at that. That's good. So let's go ahead and get out of that. You can also do exit or buy either way, and you're out of there. So the next thing that I want to show you is Sshfs. So what I'm going to do is I'm going to create a directory over here we're going to call shared documents. Just like so. So we'll copy. And I want to do this because I don't want any typing errors, and when I'm talking and typing I make mistakes, as you've already seen. So we need to make a directory. This gives us some place to mount something here. And we're going to call that directory shared documents. Now, if I grab this whole command, we're going to use Sshfs, except I need to change that. Let's see. Let's do this right here. Sshfs. And we will do this, and we will copy that. And I'll come back over here, and I'll put this in, and I want to change this to the other machine. All right. We are now connected to that other machine. And to show that, let's open up a file manager here on the host machine. And you see we have shared documents. When I click in there, look what shows up. This is the documents directory on that other machine. And we have set this to reconnect. So even if that machine goes down, it will reconnect. It knows it's there, and it will go. And this has made a very robust connection. But we haven't had to click on a bunch of things to set up file sharing or deal with the intricacies of the Samba configuration file. Big pain in the butt. This is pretty awesome. Now you can make this stick by writing scripts that you put in your startup. You put that command that we just put here, put it in your startup for your desktop, and automatically it will go connect to whatever machine you want to. Or you can write a more in-depth script, and in that script you could have many different connections that you do to set up a whole network, and it'll work just fine. So once you're through playing around with that, to get rid of it, you need to sudo u mount, and then we'll shared documents. I think this is how we do it. So let's go ahead and do that. Now we've unmounted that, so we have turned that share off. That's as simple as it gets. So what other things can we do here? Let's talk a little bit about X forwarding, because this is a very powerful thing that SSH can do. So what we've looked at so far is terminal-based stuff. So if I log into this machine yet again, so we're into the machine my son's sitting there playing games on, and I'll show you that he's logged in and playing a game right now. Let's look at users. See, I'm logged in through SSH, and he's on another command that does that. Let's see, this one will give you a better one. Who, and it tells you what, you know, how you're logged in and all that crazy stuff. Okay, see, and it shows here what machine I am logged in from. So isn't that pretty cool? Okay, what were we doing? Now I was going to show you forwarding. So what I'm going to do, let me clear this, is I'm going to run gnome disks. Well, we all know that gnome disks is a GUI application, graphic user interface, right? What this is going to do now is it's going to start the application on the other machine, and it's going to send commands through our encrypted tunnel that we have on the network to show the local machine what to actually draw on the screen. Now this does take time, especially through kind of a slow Wi-Fi network. This is really useful with applications that are quite simple. You don't really want to try and do this with your mail client, or you don't want to do it with a browser or something like that. Actually, Thunderbird works quite well this way. But if you try and do Google Chrome or Firefox or something like that, it'll take forever to load. Because what we've done here is we've taken advantage of the fact that X, which is the still default display server for the Linux system and Ubuntu and Linux Mint right now, what it does is it's a client-server relationship. So right now, our local machine is the client, and the remote machine that we're running this from is the server, and it's getting that information through our SSH connection right here. So now we can look at the health of the disk on the other machine right there. That's what it looks like. And when I close it, it takes us back to our terminal. Another trick that you can do, and you can do this from any terminal, this is just a little bonus here. If you give it the name of the application and an ampersand, you can start this application through the network yet again, but we're doing it in the background. And this will, see how it sent us back to a prompt? And then we got a message there that says we've got a job and it's running. So what that tells us is that we have one job running in the background, and that number there is the process ID right here. All right. So GNOME disks should pop up here in just a moment if everything goes. There it is. So this is running through SSH, but we still have access to the machine running on the other side of the room here. So even though I'm running disks, I can still let's run updates. You guys have seen my up script. So we can run updates on this other machine while we are working with the disk drives on the other machine and checking to see how they're doing. So that is X forwarding. That's how that works. The performance of any application which is X forwarded is going to depend on the speed of your network. So if things are running slow, then it's going to lag quite a bit. Just something to keep in mind there. Okay, so I closed that application in the background, and that's gone now. So I can go ahead and log out. A message should pop up, may or may not pop up, that says that job is done in the background. Sometimes it does, sometimes it doesn't. It didn't this time. That's okay, you get the idea. It's no big deal. So we will exit. And the last thing that we want to look at, there it is. It says our job is done. It put it right at the logout information. So the next thing we want to talk a little bit about is scripts and how you can automate things. And we'll also talk about some other utilities that allow you to transfer data through SSH. One of the very powerful things that you can do with SSH is use utilities that take advantage of that secure connection to do things like transfer files. You can run backups over a network. You can do all kinds of goofy stuff. Two that you're definitely going to want to learn about is SCP, which is Secure Copy. Basically, that's just if you want to send one or two files over the network over to another machine. And the other one is rsync. Rsync, if you give it a host name or an IP address of a machine on the network as a destination or a source, what it will do is it will automatically fire up SSH in the background, and it will go ahead and do the job. So if you have it set up with keys, then you need to do that, because if you're going to be doing anything automated with SSH over a network, you're going to have keys installed, because you really don't want to be typing in passwords for everything that your script does. This is a utility that I have written for myself. It is called sync all, and there was a script before that called sync it. Now what this does is it allows me to sync all of the files on my network with any other machine, on my local machine with any other machine that's on the network. So there are directories which I synchronize, and if we go down here you can see what they are. So I synchronize bin, which is my local place for scripts and compiled programs. I sync the desktop, I sync documents. I don't sync downloads because there's a lot of big files in there that I keep on my main machine, and on my other machines I don't really need those to be on there. But I do have the code in here just to kind of keep things where it makes sense with the normal conventions of how a home directory is laid out. So I sync music, I sync pictures, and I don't sync videos because I only keep videos on my main machine. I don't keep them on the laptops and the other stuff on the network. So that's basically how this works. So what this does is when you fire it off, it goes out and it uses Ifconfig, and it goes and finds the IP address for this local machine. So it knows not to try and sync to itself. And then it goes out and finds the other machines on the network. It checks to see whether they are there, and then does this transfer function right here. So you can see what that looks like right there. Now, this might look like gobbledygook just looking at it, but it's actually pretty cool. So all you have to do is, if I wanted to move this to another network, I can change the variables and put in different IP addresses. Let me see, where is that in here? It is down here, well, right here, set net IP. So this tells the system how the network is set up. This is a 192.168 network, and that is set up right there. So that tells that, and then it sets the host IP and the local IP. So let's go ahead and run this so it makes sense. So I'll show you how it works. So what I'm going to do now is I am going to sync all of the files on my local machine, Big Boy, to any other machine that this program can find on the network. So let's go ahead and do that. Sync all is the command, and I just turn it loose. And it's going to go scan the network. Number 12 is not up and running. 13 is up and running, so it scans that. And you see that we pulled in the, remember how we pulled in the bin directory from that other machine? That's what that just did. So what did it actually do here? Well, I've got my notes here just got synced up, and let's see what's happening here. Syncing bin, sending in a minute. So it grabbed those files because remember we changed those, we backed them up, and that's it. That's how it works. And then it looked to see that if 14 was on the network, it's not. So right now I have 3 other machines besides this one that could be up and running at any given time. I could take this a step further, and I could automate this particular little script to run automatically in the background. So if the machine's up, it just does it. But I'm kind of like, I want to see it run, so I don't do that. But you get the idea, right? This is how it works. And the sky's the limit, what you can do with SSH. It is an absolutely awesome, crazy, fun program. And as before, anybody who wants a copy of this, please send me a message through easylinux.com. Just go to easylinux.com, the contact page, and I will attach this in an email. This is very much specific to my network. It will not automatically work on your network, but I don't mind sharing it because maybe you could adapt it if you wanted to. So just send me a message through easylinux.com, and I will send you a copy of the sync all script. Greetings and salutations! That's what I say at the beginning of the video. I figured I'd say it at the end as well. For those of all of you guys who are hanging around this long, man. Thank you for watching. I do appreciate it. And it is very cool to have so many people interested in the content that I put on this channel, especially with the low production values and all of the little things that make these videos unique. But I guess maybe that's part of the attraction. This video took quite a bit to get put together because I have been helping somebody trying to get started with SSH. In the process of doing that, I realized that I forgot how to do it. Honestly, it's just that I have set this up so long ago, and all of the utilities and everything, I wrote all this stuff and did it so long ago that I forgot how I did it. So I actually had to go back and relearn how to do all this myself, and that was a very good educational experience. So thank you very much, Bill W., for pushing me into doing that and relearning what I'm doing, and I certainly hope that this is a big help. And we just barely skimmed the surface on this video. I mean, just barely. So there's so much to learn about SSH. I do encourage you to go off and read what you can about it. Just start searching on the internet. You're going to find all kinds of different opinions, different commands, options, stuff like that. Have at it and have fun. Your feedback is always welcome. And do check out easylinux.com for more about Linux. Also, that's where you can contact me. You can join the discussion at Easy Talk. That is our very own forum. It's free, secure, and a lot of fun. So check out Easy Talk. There's a link to it right from easylinux.com. And be sure to give Easy Linux a like on Facebook if you are a Facebook user. We have lots of people who hang out over there and make comments, and I post all kinds of goofy stuff all the time, so you can check that out too. So thank you for watching. And I already said greetings and salutations, so I won't say that. This time around, I will actually say goodbye.